Key takeaways of this lesson. Go supports double OP, just different way. No classes, no traditional inheritance, but all four pillars, encapsulation, abstraction, inheritance, and polymorphism are possible. Struct are the building blocks. You use struct instead of class. Hello everyone. Today we are going to discuss about object-oriented programming in Golang. Key double OP concepts. Encapsulation. Encapsulation is all about hiding internal details and only exposing what is necessary. Abstraction. Abstraction means focusing on what an object does, not how it does it. Then we have inheritance. Inheritance lets one type reuse the behavior of another. Finally, we have polymorphism. Polymorphism means one interface which can have many implementations. Let's discuss about benefits of double OP. Modularity. Double OP promotes modular approach to code design, make it easy to manage and maintain large projects. Reusability. Inheritance and other double OP concepts allow for code reuse, reduce redundancy and development time. Maintainability. Double OP principles make code easy to understand, modify, and debug. Extendability. Inheritance and other double OP concepts enable developers to easily extend and modify the functionality of existing code. Security. Encapsulation and abstraction can be used to protect sensitive data and enhance the security of software. Let's discuss how Golang achieve these double OP concepts one by one. First, we have encapsulation. Encapsulation is all about hiding the internal details and only exposing what is necessary, like using private variables and public methods to access them. In Golang, we do this by using unexported fields, which start with lower cases, and use getters and setters methods. Here in this example struct person, we have name, which is exported one. Name started with capital letter, uppercase letter. Then we have unexported field age, which start with lowercase. Then we have receiver functions for set age and get age. Like this, we can achieve encapsulation in Golang. Let's take a look at how Golang achieve abstraction. Abstraction means focusing on what an object does, not how it does it. You interact with the interface, not with the internal code. In Golang, interfaces let us define behaviors without worrying about the implementation behind it. Let's look at some code example to understand this. Understand how we achieve abstraction in Golang in more detailed way. In this code example, payment method is an interface that defines the abstract behavior pay. Then we have credit card and PayPal, which are concrete types that implement that behavior pay. Then we have make payment function, works with any type that satisfies the payment method interface. In this way, we can achieve abstraction in Golang. Let's discuss how Go achieves inheritance. Inheritance lets one type reuse the behavior of another. It's like a child inherit traits from a parent. Go doesn't have classical inheritance, but it uses composition through struct embedding to achieve the same idea. Let's look at some code example to understand this much more easily. In this code example, we have animal struct, which has a name attribute. Then we have dog struct, which has breed and animal as its embedded struct. Then you have cat struct, which has color attribute and animal as a embedded struct. Notice how dog and cat embedded animal. That is the Go's way of reusing the code, like inheritance. Polymorphism. Polymorphism means one interface, many implementations. Different types can behave differently but be treated the same. In Go, any type that implements a method can automatically satisfy an interface. This is how polymorphism works in Go. Let's take a look at some code example. In this code example, shape is the interface, the abstract behavior. Circle and rectangle are concrete types implementing the area method. The function print area accepts a shape. So it can work with any type that implements area. That's how polymorphism works with Go. Key takeaways of this lesson. Go supports double OP, just different way. No classes, no traditional inheritance, but all four pillars, encapsulation, abstraction, inheritance, and polymorphism are possible. Struct are the building blocks. You use struct instead of class to define data models. You can attach method to struct with method receivers. Interfaces. Abstraction plus polymorphism. Go's interfaces are implicit. Any type that implements the method is considered to implement the interface. This leads to super flexible and decoupled code. Composition over inheritance. Go prefers embedding struct over extending them. You can reuse behavior without a rigid class hierarchy. Encapsulation is handled by visibility. Exported capital letter public. Unexported lowercase letters private. You can use getter and setter methods for control.